Good morning, parents, teachers, and learners. Welcome to Valenzuela Live. We are now on our week 4 of quarter 3. Our topic for today is about normal random variable. In this lesson, you will learn to first, identify regions under the normal curve corresponding to different standard normal values. Next, converts a normal random variable in a standard normal variable, and vice versa. And last, computes probabilities and percentiles using the standard normal table. Before we begin the lesson proper, let us have a review on characteristics of a normal distribution. Are you familiar with the game Crossword Puzzle? Well, our activity is like crossword puzzle but with a twist. Instead of showing words or phrases of hints, I will be showing you a picture that describe one characteristic of a normal distribution. After flashing the picture, the 10 seconds timer will count. Remember that a word can only be formed by a continuous horizontal or vertical row of letters in the crossword puzzle. Are you ready? Let's begin. Picture number 1. It is a 10-letter word. Your timer starts now. The word is asymptotic. The distribution curve is asymptotic to the x-axis. Normal distributions are continuous and have tails that are asymptotic, which means that they approach but never touch the x-axis. Picture number 2. Picture number 2 is an 11-letter word. Your timer starts now. The word is symmetrical. The curve is symmetrical about the mean. The right side of the center is a mirror image of the left side. Thus, if the total area of the curve is 1 or 100%, then both left and right side has an area of 0.50 or 50%. Picture number 3 is a 10-letter word. Your timer starts now. Correct. The word is bell shape. The normal distribution curve is a bell shape. One way of figuring out how data are distributed is to plot them in a graph. If the data is evenly distributed, you may come up with a bell curve. Picture number 4 is a 5-letter word. Your timer starts now. Very good. The word is equal. The mean, median, and mode are equal and located at the center of the distribution. The center of a normal distribution is located at its peak. It follows that the mean, median, and mode are all equal in a normal distribution. Picture number 5 is a 10-letter word. Your timer starts now. Very good. The word is unimodal. A normal distribution curve is unimodal. A unimodal distribution is a distribution with one clear peak or most frequent value. The values increase at first rising to a single peak where they then decrease. The normal distribution is an example of a unimodal distribution. Let us now move to the next part of our lesson. This time, you are going to react on me. I will show a picture, then you will react hard if the graph is normally distributed, and laughing emoji or haha if it is not. I will give you a 5 seconds to think of your answer. Are you ready? Let's start. First picture. The answer is laughing emoji. First picture is not normally distributed since it does not have a bell-shaped curve. Second picture. The correct reaction is heart. Second picture is normally distributed since it has a bell-shaped curve. Third picture. Very good. The emoticon is heart. Third picture is normally distributed since it has a bell-shaped curve. Fourth picture. Your 5 seconds starts now. The correct answer is laughing emoji. Fourth picture is not normally distributed since it does not have a bell-shaped curve. From this activity, we observe that the second and third pictures are both normally distributed even though they have different mean and standard deviation. Always remember that the normal probability distribution has a continuous random variable and it uses two functions. First, to determine the height of the graph, representing the distribution, and second, to determine the probabilities. To avoid unnecessary calculations and graphing the scale of a normal distribution curve, we can convert this normal distribution to standard normal distribution scale, called the z-score or standard unit scale using this formula. Z-score is equal to x minus mu all over sigma, where z is the standard score, x is the observed value, mu is the mean of the population, and sigma is the standard deviation of the population. It is useful to standardize the values of a normal distribution by converting them into z-scores because it enables us to compare two scores that are from different samples, which may have a different means and standard deviations. And it allows researchers to calculate the probability of a score occurring with a standard normal distribution. Ma'am, you have mentioned one of its importance is to calculate the probability of a score. Does it mean we will solve and prove the probability of a z-score? Good news! We shall not use the formulas to calculate the probabilities under the normal curve. They are already available for our use. Here is the table I am referring to. The standardized normal probability table. Let us learn more about normal probability distribution by analyzing the following examples. Example number 1. If x is distributed normally with mean of 100 and standard deviation of 50, find the z-value when x is equal to 200. Mean and standard deviation is given in the problem, and we are asked to convert x, which is equal to 200, into standard normal distribution. To do this, let us simply plug in the given z-score formula. Once again, z-score formula is equal to x minus mu all over sigma. Using this formula, we have z-score is equal to the value of x is 200 minus the value of mu is 100 all over the standard deviation given is 50. In addition, we have 200 minus 100 is equal to 100 divided by 50. 100 divided by 50 is equal to 2. Therefore, z is equal to 2. It means that the x value of 200 in normal distribution is equivalent to 2 in standard normal distribution. Always remember that in a standard normal distribution, the mean is at 0 and the standard deviation is always 1. Example number 2. Suppose x is normally distributed with mean 8 and standard deviation 5. Find A. The probability of x less than 8.6. B. The probability of x greater than 8.6. And C. The probability of x greater than 8 but less than 8.6. To answer letter A, let us follow these steps. Step 1. Draw the normal curve with mean of 8. Locate where the x value given, which is 8.6, is placed on x-axis. Where do you think 8.6 located? Is it on the left or on the right side of the mean? Correct. 8.6 is greater than the mean, so it is written on the right side of the mean. Now, we are asked to find the probability of x less than 8.6. Which do you think is the shaded part? Is it on the left or on the right side of 8.6? Very good. The shaded part is on the left side of 8.6, since all the values on the left side of x-axis are less than 8.6. Step 2. Convert the given x value to z-score using the z-score formula. Z-score is equal to x minus mu all over sigma. The x given is 8.6 minus the mean of the population is 8. So we have 8.6 minus 8 all over. So sigma given is 5, or the standard deviation given is 5. So we have z-score is equal to 8.6 minus 8 is equal to 0.6 divided by 5. 0.6 divided by 5 is equal to 0.12. Therefore, the z-score is equal to 0.12. Step 3. Using the standardized normal probability table, find the probability of z, which is equal to 0.12. Remember that in finding probability, the units place and the first decimal place are shown in the left-hand column, and the second decimal place is displayed across the top row. The probability of the given z-score is on the intersection of the row and column. Thus, the probability of 12 hundredths or 0.12 is 0.5478. Next given is probability of x greater than 8.6. To answer letter B, let us follow these steps. Step 1. Identify the area of shaded region. Since the given is x greater than 8.6, then we will shade the right side tail of 8.6. Step 2 is to convert the normal distribution into standard normal distribution. From example 2a, We already solved the equivalent z-score, which is 0.12. Also, we already knew the probability of z-score less than 0.12, which is 0.5478. But 0.5478 is the probability of z-score less than 0.12, which is shown by the blue shaded part of a normal curve. Instead, we are asked to find the probability of z-score greater than 0.12, or the red shaded part of the curve. To solve this, we will apply one of the characteristics of a standard normal distribution, which says that the total probability of a standard curve is equal to 1. Therefore, the probability of x less than 8.6 plus the probability of x greater than 8.6 is equal to 1. Since we already converted the x values, we will now have the probability of z less than 0.12 plus probability of z greater than 0.12 is equal to 1. The probability of z less than 0.12 is 0.5478 plus probability of z greater than 0.12 equals 1. Solve probability of z greater than 0.12. This is equal to 1 minus 0.5478. Therefore, the probability of x greater than 8.6 or the probability of z greater than 0.12 is 0.4522. Let us now solve letter C. The given is the probability of x greater than 8 but less than 8.6. To answer letter C, let us follow these steps. Step 1. Identify the area of shaded region. Since the given is x greater than 8 but less than 8.6, then we will shade the area between 8 and 8.6. Step 2. Again, from example 2a, we already solved the equivalent z-score, which is 0.12. This time, we have two given x-scores, the 8 and 8.6. We already solved the probability of z-score less than 0.12, which is 0.5478. Since 8 is the mean of the normal distribution, then we can say that 8 is equivalent to 0 in standard normal distribution. As states in one of characteristics of a standard normal distribution, that 0 is always the mean of the curve. So, we just need to find the probability of z-score less than 0. Using the standardized normal distribution table, we can say that its probability is 0.5. Now, to solve the probability of z-scores between 8 and 8.6, we will simply subtract the probability of z-score less than 0.12 and the probability of z-score less than 0. So, the answer is 0.0478. Let us try this problem to know more about the normal distribution. The percentage of students at school between 1.1 meter and 1.75 meter tall is 95%. Assuming that the data is normally distributed, calculate the mean and the standard deviation. Construct the normal curve corresponding to the data. To solve this problem, let us drop the given in a normal curve. We have two given x-scores, the 1.1 meter and 1.75 meter, which the mean is between these scores. So, to solve this, we simply get the average of these two scores. So, 1.1 meter plus 1.75 meter is 2.85 meters divided by 2. The mean is at 1.425. Next is to identify the z-score of the given percentage, which is 95%. But since normal distribution is asymmetrical, which total probability is 1, it implies that the area of unshaded part for both left and right tail is 2.5%. Therefore, the area of x-score less than 1.75 meter is 97.5%. Use the table and identify the closest z-score which has the probability of 0.9750 or 97.5%. Based from the table, its z-score is 1.96. We will now substitute all the given in z-score formula to solve for standard deviation. Z-score is equal to x minus mu all over standard deviation. Z is 1.96 equals x is 1.75 meter minus mu is equal to 1.425 meters divided by sigma or the standard deviation. 1.96 equals, so we have 1.75 meters minus 1.425 meter equals 0.325 meters over standard deviation. Cross multiply, we have 1.96 standard deviation or 1.96 sigma equals 0.325 meters. Divide both sides by 1.96, we have sigma or the standard deviation is equal to 0.17 meters. To wrap up today's lesson, answer the following statements with true or false. I will give you 5 seconds to answer. First statement, a standard normal distribution is always a normal curve. Your 5 seconds starts now. Correct. The answer is true. Second statement, the area under a normal curve is 1%. Your 5 seconds starts now. Very good. Statement number 2 is false because the area under a normal curve is 1 or 100%. Third statement, in a standard normal distribution, the mean is 1. Your 5 seconds starts now. Yes, statement number 3 is false because the mean is always at 0. Fourth statement, the normal curve is bell-shaped. Your timer starts now. Correct. Number 4 is true. And last, number 5 statement, a z-score is also called a standard score, which gives you an idea of how far from the mean a data point is. Your 5 seconds starts now. Definitely, statement number 5 is true. Good job, grade 11 students. And now, for your activity, answer page 19, assessment part of your statistics and probability learning packet. And if you have any question, just ask your subject teacher during your follow-up discussion. Before I end this video, I want to read a quotation from Maya Angelou. If you are always trying to be normal, you will never know how amazing you can be. Because if you are trying to conform to what people tell you is normal, then you are trying to live someone else's version of life. I encourage everyone to go out of your comfort zone and build the best version of yourselves. I am Miss Gretchen May Gementiza from Valenzuela National High School, saying thank you for watching.